Hello all, welcome. Numerical text of today. Electric setting under the Sagata. So this is the last part of our video series as an attempt for PGCET Electrical Sciences chapter question solution, and this will be very useful for preparation of KEA exam of KPTCL 2022. Let us look at the questions then. So this is about basic question which will generally be asked, and it is from, again you can say that it belongs to the category of electrical power system. Okay, let's look at the question. When there is change in load, so this mainly speaks about change in load in a power station which has number of generator units operating in parallel. The system frequency is controlled by. Okay, so basically it is how the system frequency is controlled that has been asked. Okay, so there are many ways by which we can control the system frequency, but one basic approach, as we know, that speed and frequency, the relationship between speed of an alternator and the frequencies are directly proportional to it, right? Now, if we can just look at the options available here, option B says that the frequency can be controlled by adjusting the field excitation. That is, by adjusting the field excitation, what we can control is we can have a control over the generated voltage, but we don't have any control over the frequency. Similarly, changing the load division between the units can practically have the impact on controlling the system frequency, but that will also not a very practical viable solution with respect to the options whatever are given over here. Similarly, injecting the reactive power is not a very suitable option. Okay, so we are speaking about with respect to whatever the options given over here, right? So with that sense, option A, adjusting the steam input to the units, that as adjusting the steam inputs to the unit can lead to have a control over N, and that is how we can have a control over the system frequency. Next is again, this is from electrical power system. It says that the positive and negative sequence impedance of a transmission line. Okay, actually the positive sequence impedance and negative sequence impedance of a transmission line, they are equal, but this might not be the case for for transformers, for alternators, for generators and all. The positive sequence and negative sequence components may vary, but as you can see here, if it is a fully transposed three-phase line which is completely symmetrical, as we know that a complete transmission line is always a complete symmetric one, hence the positive and negative sequence impedances are independent of the phase sequence and are actually equal. They are actually equal, that is x0, x1 is equal to x2 for a transmission line. So this is a very simple question from the subject power electronics. It says that silicon control rectifier is a unijunction device. No. Whether it has 4 junctions? No. None of this is also not a valid option. But if we can see the structure, we know that here we have one junction, and this N and P makes the second junction, and this P and N makes the third junction. Hence, SCR, or a silicon control rectifier, or popularly known as thyristor, has 3 junctions. This is again a continued topic about the power electronics. The thyristor is turned off when the anode current falls below. So remember that there are 2 concepts in the transistor turn off behavior. One is called as leading current, another one is called as latching current. Okay. So remember that latching current is nothing but a minimum amount of current which is required to turn on a transistor. Just try to understand the meaning and usage of the word. Latching current is nothing but a minimum amount of current which is required to latch or to learn or to turn on or to have a something like turning on process. For that we require a minimum amount of current. It's called as latching current. Whereas holding current is actually comes into picture at the later stage. That is whenever a transistor is turned on. So then at the later part, the concept of holding current comes. That is, once the thyristor is latched, a minimum amount of current is also required to hold it on state, right? So basically what happens is if the thyristor is generally turning off, mean to say that its anode current must fall below the holding current. If the holding current of a thyristor, if the anode current, if it falls below the holding current, then the thyristor turns off. Okay. So latching current and holding current, they are put together different concepts. And holding current is a minimum current which is required to maintain the on state. That is very much important to understand. Next is about the Ward-Leonard system, which is used for controlling the speed up. Generally, this Ward-Leonard mechanism is a very basic mechanism which is used for the speed control of DC motors. As we can understand here that this is a basic control system which uses motor M1 powered by a DC generator G. Right. So in this method, generally what happens is the speed of motor M1 is controlled by applying the variable voltage across the armature, and generally the variable voltage is obtained by using another set of motor generator with M2 motor. So the motor M2 might be AC motor or DC motor which is directly coupled to the generator, and it is a very popular method of controlling the speed of DC motor, and is a widely accepted concept in DC motor speed control concept. So next is about the speed of DC machine at rated armature voltage, rated field current, and rated armature current is known as. It is called as maximum speed. It is because base speed, average speed, and none of these are not valid options. Okay, because we are speaking about armature current, field current, and even the armature voltage. Altogether, all of them are maximum. Okay, so this will generally lead to a maximum speed of motor. So option B is the correct answer for this question. Next is a DC generator has an EMF of 100 volts. Okay. A DC generator has EMF of 100 volts. Let's say that this is E1 is equal to 100 volts, and useful flux is 20 with the 10 to the power 3 watts. And for this, speed is 800 RPM. Now what we have to calculate is, we have to calculate E2 for same value of flux, but speed of the motor is now changed to 1000 RPM. Okay, that is asked in this question. Now basically what we can say is for a DC generator, since we know that from EMF equation, that is E is equal to P5 N Z by 60, and from this we can deduce that E is proportional to N. Right. So since E is proportional to N and P is not given over here, and flux remains constant in both the cases, means we can also neglect this. Z is not given, this information is also not given, this is a constant. Right. Now as you can say here that E is directly proportional to N, we can have a ratio of E1 by E2 is equal to N1 by N2. Right. So this, if we can solve, then we will get that E2 is equal to P1 N2 divided by N1. Right. So this will be basically how much? 100 into 1000 divided by N1, which is 800. Okay, it is basically 1000 by 8, which will be 125 volts. So 125 volts we have here option A. A very similar kind of working out with the ratios we have to calculate here. But now this is with respect to a concept of transformer. It says that a transformer has 800 primary turns, that is N1 will be equal to 800 turns, and N2 will be equal to 200 turns, and it is supplied by 100 volts. So P1 or whatever we can say P1, which is 100 volts. Now we have to calculate P2. How much is P2? Right. For transformer, we have a well-established formula which says that N2 by N1 is equal to P2 by P1. Okay. N2 by N1 is equal to P2 by P1. So if we can solve for this, then we know that is 200 by 800 is equal to P2 by. Now if we can solve for this, then we shall get the answer as 2.5 volts, which is option B. Next is with respect to coupling of alternator and induction motor. Okay, let us look into the question and what are the factors we have to calculate. It says that 8-pole alternator runs at 750 rpm and supplies power to a 6-pole induction motor, which has a full load slip of 3%. The full load speed of the motor is, now we have to calculate the full load speed of the motor. Okay, let us try to have the solution for this. For alternator, if I have to calculate MS, then you know that is 120 F by T. Okay. So since nothing is mentioned about the frequency here, let us take this as 50 Hz. Now if you can solve for this, it is 750 rpm, and that is how is cross validity for an alternator. Now we have to calculate the synchronous speed for induction motor. We have to calculate synchronous speed of a given induction motor. Again, we shall apply the same formula that Ns is equal to 120 F divided by T. So T is now 6 volts. So if we can solve for this, we know that it will be 6000 divided by 6, which is 1000 rpm. So 1000 rpm is the synchronous speed of induction motor. That is 750 rpm is the synchronous speed of the alternator. Now we know that if we have to calculate the speed at which the motor is running, then the formula is N is equal to Ns into 1 minus S. Okay, remember that slip here it is given that slip is 3%, which is nothing but 0.02. Now if we can apply this, it is 1000 into 1 minus 0.0. Okay, it will be basically 1000 minus, okay, it will be 970 rpm. Okay, 970 rpm, which is option B. In this case, is the answer. Next is it is about the construction of alternator. It is again a part of electrical machines. Remember that electrical machines and electrical power systems can fetch more marks in these kind of exams. Okay, let us look at the problem definition. In a 36 slot 4-pole 3-phase alternator, the winding pitch is 7 slots. Okay, it says that there are actually how many slots? There are actually 36 slots are there, and it is a 4-pole motor. Now, actually, if we calculate slots per pole, okay, if we can calculate slots per pole, it is 36 divided by 4, which is 9. But it has been already mentioned that the winding pitch is 7 slots. The winding pitch is 7 slots means now we can calculate 20 slots as 9 minus 7, which is equal to 2. So 2 slots are actually 20. Now, if we have to calculate the electrical angle at which the winding is corded is equal to, okay, this is basically given by 180 degree into 20 slots divided by slots per pole. Okay, if we can apply this, it is 180 into 2 divided by 9, which is 40 degrees. Okay, so 40 degrees corresponding to option B. So the next question is about the relationship between annual cost of energy wasted in an overhead transmission line and area of cross section is given by. Okay, it is generally given by the expression as P3 by A or power by A, and power is about what we are speaking about the power losses. So the relationship of area, whatever we are speaking about, is inversely proportional to A. And we can just go to the relevant explanation given here. Next is about a basic concept of electrical wire, which has a diameter D, and the fusing current is given by. Okay. So for a round wire of diameter D, the fusing current is given by each of the following options available here. Right? We know that the resistance of the wire. The resistance of the wire actually determines fusing current, right? So less the resistance, more is the fusing current. That is the concept here. And the resistance per unit length is given by rho divided by pi d square by d by 2 square, right? And if we can solve for this, we know that power per unit length is given by I square r, which is, if we can solve for this, we will get it as I square rho divided by pi half d square, right? And we know that the temperature of the wire is given by T is equal to Kp by rho. So if we can solve for this with T as the fusing temperature, all the parameters except I and D are deemed as constant, right? So I square is proportional to dq, and the fusing current is proportional to d to the power 1.5, which is nothing but option B. So you can go through the detailed solution given over here. Is option B. Next is about there is a delta connected load. Just we can look into the actual system how it will look like. There is a delta connected load. It is about one is corresponding to R phase. So that is corresponding to R, Y, D, here also we can define that the current in this case is I0, the current in another case is I5, and the current in third case is I. Now what has been asked is a delta connected load from a three-phase supply is there, and fuse in B line is removed. That is, it is clearly saying that B is becoming an open circuit. Okay. B is becoming an open circuit because the fuse is open. So since the fuse is open, it becomes open circuit, means this particular part will be now open. So if this part is open, we have to calculate the various other line currents by considering R phase current as a reference current, right? And the current in the other two lines are 20 amperes. Now, if we can just look at the required answer for this, now easily we can determine that since for B phase it is open, so that IB will be equal to 0 amperes, whereas IR is the reference phasor. As the data given here, this is the reference phasor which is 20 at the angle 0 degrees. So that the other current, it becomes 20 at an angle 186 degrees, right? So that the answer now we can mark that IR is equal to 20 at an angle 0 degrees, IY is equal to 20 at an angle 180 degrees, and IB is equal to 0. It is because since out of the three phases available, one phase is opening up, we can easily say that if one is the reference at 0 degrees, then the other one will be exactly at the dead opposite side of the spectrum. So if this is a phase reference, then this is the other will be exactly at the dead opposite of the spectrum. Let's say it is 0 degrees and 180 degrees. Take the magnitude of the current remaining same, that is 20 amperes. Now, peak inverse current for a power diode is given by. So the peak inverse current is given by the expression E into di by dt, whereas di by dt is the rate of change of current with respect to time, and P is the, since we are speaking about here, peak inverse current. The peak inverse current. So P is the time required for this. Okay, so time into rate of change of current with respect to time determines peak inverse current. About power transistor, if the forward current gain is 0.97, then we have to calculate what is beta. So we can use the formula given over here that alpha is equal to beta divided by beta plus 1. So if we can solve for this, it becomes alpha beta plus alpha is equal to beta. Okay. Now if we can solve for the parameters by substituting as alpha is 0.97, beta plus 0.97 is equal to beta. Okay. So the complete solution of this will turn out to be 32.2. You can just refer with the answer, which is option. Okay friends, hope this solution part, whatever we have discussed in our video, helps you all in long run for your preparation of KEA exams. Wish you good luck. Please subscribe to this channel if not yet you have subscribed. Thank you.